Again, this is a really famous limit, and you're going to see this limit again in the last chapter. I believe it's chapter 9. It's a very famous limit. The question is, how do we find this limit as x goes to infinity? The first thing we should always try to do is what is happening. You know, what value do we get, like infinity over infinity or 0 over 0? What is happening here as x goes to infinity? First, look at the inner portion. What is happening to the inner portion? We have 1 plus, okay, where does 1 over infinity approach? 0, right? 1 over infinity goes to 0. And on the power, you have infinity. So what we have is we have something of the form 1 to the infinity. Now, the thing that we have to be careful about is to recognize this is not exactly 1 to the infinity, but what it really is, the bottom is approaching to 1, and the top is approaching to infinity. Because if you had exactly 1 to the power of infinity, what would the answer be in that case? If you have exact constant of 1 to the power of infinity, that would be exactly 1, right? The 1 times any number of itself is going to be 1. But the key here is the bottom is not 1. The bottom is approaching to 1, because the bottom is technically 1 plus 1 over x. That 1 over x part is going to 0, so the bottom is approaching to 1. The top is approaching to infinity. So the question is, you know, again, two powers are at play here. Which one is going to succeed, or maybe somewhere in the middle? Now, any suggestions how I could start this problem? Any suggestions? Apply ln. Grace's suggestion is a good one. How do we know we're going to apply that technique of applying ln to both sides? By the way, your group activity, I believe question number 1 had a problem just like this one, where you have to apply the ln. How do you know you have to apply the ln function? The x power, also the x base. If you have a variable base, on the inside the parentheses there's a variable, right, and on the power there's a variable, then you know that this is a good approach. So let's do that. Let's y be equal to the given expression. Let y be equal to 1 plus 1 over x to the x. Then we're going to apply ln y to both sides. Ultimately, we're going to need to get rid of the ln y, but right now we're bringing in temporarily to help us with the problem. Okay, as I bring in the ln y, I'm going to also do a simplification. This can be written as x times ln of 1 plus 1 over x. Did everybody see what happened there? Basically, I applied ln to both sides. At the same time, I brought the power down. That is a property of logs. We can't do that, right? Only with logarithmic functions. Okay. Now let's see what happens. If you were taking a limit as x goes to infinity, if you were taking a limit as x goes to infinity of both sides, what would you have on the right-hand side? Okay, x, just that's going to infinity, right, times ln of 1 plus 1 over x. What would that be? Ln of, as x goes to infinity, first look at the inner part, 1 plus 1 over x. Where is that going towards? One plus 1 over x is going towards 1. How about ln 1? Where does ln 1 go? To 0, right? Ln 1 is 0. So now we have something of the form infinity times 0. Now we're a little bit closer to applying Lhopitals rule, because anytime you have infinity times 0, there is a way to rewrite it as either infinity over infinity or 0 over 0. You just basically flip one of the expressions and put in the denominator as follows. We can rewrite this as ln of 1 plus 1 over x divided by 1 over x. Are we still taking a limit as x goes to infinity? And on the right-hand side, limit as x goes to infinity. Okay. Why did I bother doing this? By the way, do you agree I can do this? If we go back and check our answer, if you're dividing by a fraction, you multiply by the reciprocal, right? So this is a pretty common trick that we use. If you have 0 times infinity, or infinity times 0, you try to put one of the expressions on the bottom as a fraction. So now what do we have? The top is approaching where? 0. How about the bottom? 1 over infinity? That's also going to 0. So now this is a form that we can work with. This is 0 over 0. So now we know what to do with Lhopitals rule, hopefully, right? Okay, so what does Lhopitals rule say that we can do at this point? You take the derivative of the top first, and then take the derivative of the bottom separately, right? Okay, first of all, derivative of ln of 1 plus 1 over x. What is in general derivative of ln u? 1 over u times u prime, right? From the chain rule, you do 1 over u times u prime. Okay, in this case, okay, so as x goes to infinity, first differentiate the top, and you will have 1 over 1 plus 1 over x. Now, what is the derivative of the inside? What is the derivative of 1 plus 1 over x? Derivative of 1 is 0. What is the derivative of 1 over x? Negative 1 over x squared, right? And on the bottom, differentiate the 1 over x on the bottom. What do we get there? Negative 1 over x squared on the bottom also. And luckily, those are completely going to cancel each other. So all we're left with is limit as x goes to infinity of 1 over 1 plus 1 over x. Once again, let's see what happens to this as x goes towards infinity. Any thoughts? 1 over 1 plus 0, in other words, 1 over 1, in other words, just 1. Because 1 over x goes to 0, so we're left with 1. Now remember, on the left-hand side, we have limit as x goes to infinity of ln y. Remember, we had to take ln of both sides to begin the problem. So now you don't have the answer to the original question, but you have the question, the answer to ln y. Where does ln y go to? But we really want to know, where does the original function, which we called y, goes to? If you know ln y equals to a number, can you tell me what is y? If you know ln y is equal to 1, what can you tell me about y? Remember, exponentiation, you can exponentiate both sides, e to the ln cancel, so y equals e to the 1, right? So if you know the limit of ln y as x goes to infinity is 1, the answer to the original question then will be what? E to the 1 or e. So if ln y goes to 1, then the limit of the original question, which is what we called y to be, is going to be e to the 1 or e. And I'm just going to write the whole result one more time. So what we've found is as follows. Limit as x goes to infinity of 1 plus 1 over x to the x is equal to e. This is a very important result. Later on, we're going to see this again.